Hi graduates, we're back to solving more complex equations, which is our topic 2. So hopefully now we've practiced enough to master the basic equations, which what you do to one side, you do to the other side, and our idea of inverse operations. And now we're going to step it up a notch. And so here's topic 2, which is solving more complex equations. Don't forget to hit pause and write down all the notes so that you can study from it in future. So example 1 says, draw a flow diagram to illustrate this equation. Now the reason why we're doing this last flow diagram of ours is just so we can see our order of operations. So if this is x, if I'm putting x into a flow diagram, the first thing that I would do to x is multiply by 3. I wouldn't divide by 4 first, simply because the x is more directly attached in my kind of mind. So I would multiply by 3 first, then I would divide by 4, then I would add 1, and I would get out a value of 7. So that would be my flow diagram. Now if I'm using this flow diagram to solve for x, I would undo each of these. And so just to remind you, we use the inverse operation. So the inverse of addition is subtracting. So to undo adding 1, I'm going to subtract 1. To undo dividing by 4, I'm going to multiply by 4. To undo multiplying by 3, I'm going to divide by 3, and that will get me back to where I came from. So the reason why we wanted to do this is simply so that we notice, who do you get rid of first? Remember what we said in the last video? If I divide it into terms, you get rid of everything else in the opposite, the term furthest away from x first, which is the plus 1. So I will get rid of the plus 1 first. Then notice here, I'm getting rid of the dividing by 4 second. And when we write our notes when we're doing the examples, that's exactly what I'm going to say. I like to get rid of all my denominators first. So I would get rid of dividing by 4 and then get rid of the 3. So let's just quickly solve this. 7 take away 1 would give me 6. 6 times 4 would give me 24. And 24 divided by 3 gives me 8. So I know x is equal to 8. Now that's how I would do this question in a flow diagram. How would I do this question? Writing it down a little bit more mathematically. So let's look at example 2. Let's start off with some easier ones. What happens if I had x divided by 2? Now this should be fairly easy for us because we are already quite used to the fact that if you write something over 2, it means divide by 2. And we're used to the idea that to get rid of dividing by 2, I'm going to multiply by 2. Simply because we've already discussed the idea that division is the inverse operation of multiplication. So I'm going to multiply by 2. But what you do to one side, I need to do to the other side. So I'm going to write here a little note myself. Golden rule, giant capitals, really, really important. The moment you do something to one side of an equation, make sure you do it to the other side. Now what happens here is that my 2's cancel because 2 divided by 2 is 1. So I get 1x, or just x, and 4 times 2 is 8. Now again, I could have seen that the answer was 8 before I'd even started this question. But remember, we're trying to build up a skill set. So if this was a test question, of course, I'd say x is 8 and I wouldn't even bother showing working. But at the moment, we're trying to skill ourselves for when the questions get more difficult. Okay, let's see another one. So here's a good question. This has multiple terms. So I often say to myself, what is attached to x that I want to get rid of? That's often my first question. What is attached to x that I need to get rid of? Now, the reality is anything on the side of x has to go, because you ultimately want x by itself. So if I answer this question to myself, I can see I want to get rid of subtracting 2, I want to get rid of dividing by 5, and I want to get rid of multiplying by 4. The question is, in what order? Now don't forget that we divide into terms, and so you always get rid of what is furthest away from x first. So I'm just going to write myself a note here. Get rid of what is furthest away from x. Now what's always going to be furthest away from x is anything that's not in the same term as it. Now this subtract 2 is not in the same term. So I'm going to get rid of subtracting 2 first, and I didn't even write it down. So subtract 2, and how do I get rid of subtracting 2 is I'm going to add 2. But really importantly, if you add 2 to one side, you've got to add 2 to the other side. Now those 2 are going to disappear, which was the whole point of this. So I'll end up getting 4x over 5. The 2's have disappeared, and I get 16. Okay, now what is furthest away from x? And I always think of the denominator as the furthest away from x if it's one term. So you don't have to get rid of the denominator first, but personally I find it easier. Always get rid of denominator first. Now that's exactly what our flow diagram kind of illustrated to us. So how do I get rid of dividing by 5? I'm going to multiply by 5. But what you do to one side, you do to the other side. So these 5's land up cancelling if I just do it really lightly. So I land up with just 4x, and 16 times 5 is 80, I think. And now, finally, how do I get rid of the 4? Well, I'm multiplying by 4, so I'm going to divide by 4. But what you do to one side, you do to the other side. And so 4 divided by 4 is 1, so I land up with 1x, which I write as x, and 80 divided by 4 is 20. So this example was trying to show us, identify the 3 things that you need to get rid of, and then do it one at a time. Always start by everything that's not in the same term as x. I always think of it as everything furthest away from x, and then always get rid of denominators, simply because it makes your life easier. Okay, let's look at question C. Now question C is almost the same as B, except for this idea of it's in the wrong order. So I'm going to do it 2 ways. Remember what we learned in the last video is the order of terms doesn't matter. If you prefer to put the negative 2 over 3x first, then plus 1, that's absolutely okay. Now most people will find it easier to solve like that. Now I'm just going to write a note to myself on the side here. This question has said negative 2 over 3 and then the x. Is that the same as if I say negative 2 x all over 3? And the answer is it absolutely is the same. Simply because if I wrote x as a fraction, technically x as a fraction is x over 1. And so I'm multiplying this fraction by a fraction, and so it's top times top and bottom times bottom. So negative 2 times x and 3 times 1. So it doesn't ever matter whether you think of negative 2 over 3 as separate to the x, or if you extend that over sign. It really doesn't matter, and it doesn't change the way you solve the equation. So often they like to put both types in a test just to see if you can handle both. Right, so now that I've swapped the order to make my life more not interesting, I'd say more easy, what do I need to get rid of? I need to get rid of adding 1, I need to get rid of dividing by 3, and I need to get rid of multiplying by negative 2. Okay, now again, does it matter who that negative belongs to? And it doesn't. I always just kind of think of it as belonging to the top because it's easier. Now, which one do I get rid of first? Don't forget that you always get rid of things furthest away from x. So whatever's in the other term. So I'm going to get rid of adding 1 first. So I'm going to subtract 1 from both sides. Now that means that these 2 will cancel each other out, which was the whole point of doing this. So I get negative 2 over 3x, the ones have disappeared, equals 9. Now, I personally prefer to get rid of denominators first, so I'm going to undo dividing by 3 by multiplying by 3, and so I'm going to get negative 2x equals 27. And finally, how do I get rid of multiplying by negative 2? Is you divide by negative 2. Now, if I pick up my calculator and put 27 divided by negative 2, I get negative 27 over 2. That actually doesn't simplify. Now, you could say it's negative 13.5. You could say it's negative 13.5. It doesn't really matter. We actually prefer improper fractions in simplified form, and 27 and 2 don't simplify any further. Now, does it matter where this negative goes? It doesn't. You can either write it as negative 27 over 2, or you can write it as negative 27 over 2. We just don't like putting a negative in a denominator, so we would never leave it there. Don't also freak out if your answer to an equation question is quite a mean looking fraction. We deliberately make questions where the answers aren't wonderfully in whole numbers, simply because then it's quite easy to guess sometimes, and we want to see that you know the techniques that you've learned. Okay, so now that we've done those types of questions, let's move on to a next type of one. 2x plus 4 equals x. So immediately I see this, I would say to myself, hang on one moment, that x isn't in the right place, it's on the wrong side. Now technically there's no such thing as the right side and the wrong side, but I don't like having x's on the right hand side of an equation. So I think to myself, not a problem, we learned in the previous video that we can do the pancake flip. So I say, great, I'm going to put the x on this side, and I'll swap the other side over, which is 2x plus 4. And what do you know, I have exactly the same problem. Now, why am I having the same problem? This didn't work because for the first time, I have x's on both sides of the equation. So the moment you have x's on both sides, if you pancake flip it, you're still going to have x's on both sides. So shock and horror, we're going to have to learn a different technique now because pancake flipping didn't work for me. Now the moment you have x's on both sides, I call this is going to sound ridiculous and don't laugh, but I call these Beyonce type questions. Now I have no doubt that Beyonce does not know this, but I call them Beyonce type questions for a very important reason. In an equation, the question says solve for x. Now you can't have x's in lots of places. If you want to solve for x, I eventually want to have x is equal to something something as an answer. You can't have x is equal to something with an x. I want x all by itself. Now, where do I generally want x? I want x generally on the left because that's what I'm programmed to do. So I want all my x's to be on the left hand side of an equation so I can solve for them. And so I don't know if you know where I'm going with this Beyonce thing, but basically my whole point, if I have x's on both sides, is letters to the left. So I always think of these as to the left, to the left. Definitely not going to sing it, that would be ridiculous, but I always think of the idea of to the left, to the left. The letters need to go to the left. So from now on, I'm going to call these Beyonce type questions when there's x's on both sides, and that immediately triggers in my head, right, letters need to go to the left. So this pancake flip thing didn't work, so I'm going to start again. So what was the original question? The original question was 2x plus 4 equals x. So the first thing I do is I say to myself, oh gosh, this is a Beyonce question. And so my first step is I want all my letters on the left. So I immediately say to myself, which letters are in the wrong place? Now I've gone and written which letters on the letters. I want letters on the left. So in order to do this, I identify all letters in the wrong place. Now I'm going to write wrong in inverted commas because they're not really in the wrong place. There's no such thing. But for my method, if I want them all in one place, again, I'm writing and talking, so I'm making mistakes. So let me stop talking. So identify all letters that are in the wrong place. So I like to think of this x as in the wrong place because I want it on the left hand side. So my next question is, how do I get rid of that x? So now that I've identified the problem, how do I get rid of that x? Now the question is, what is that x? Is it a plus x? Is it a minus x? Am I dividing by that x? Am I multiplying by that x? And the answer is, it's actually a plus x there because there is no sign. And so if we understood inverse operations in the first video, this is exactly the same concept here. I'm going to use an inverse operation. So how do I get rid of that x? The answer is, I'm going to subtract x. So I'm going to take it away. Now why do I take it away? Because what is x take away x? Nothing. which means that x has disappeared. But what is the golden rule? If you do it to one side, you do it to the other side. So you can't just subtract x on the right hand side, you've got to subtract x on the left hand side. Now what I'm going to do is I'm going to spend a line just collecting up like terms on both sides. So I'm just going to simplify so then I can see where I have to go next. So on my left hand side, 2x take away x is 1x and plus 4. And the moment you've got all your letters on one side, it's back to an easy equation, because now it's back to, right, what is attached to x that I need to get rid of? So my next step is I start repeating that idea. What is attached to x that I need to get rid of? And the answer here is there's only one thing, it's adding 4. How do I get rid of adding 4? I'm going to subtract 4. But what you do to one side, you do to the other side. So from this step over here, we're back to topic 1. We're back to the easy guys. So you've only added an extra little step in here by letters to the left. So hence, I hope Beyonce one day hears how famous she is in mathematics. And I get x is equal to negative 4. Now again, you could sub that into the equation using a calculator and check if you actually do get the question right. Right, so let's try more of these Beyonce ones. So immediately I see question D. I see 3 minus 4x equals 3x plus 1. This is definitely a Beyonce type question because I see x's on both sides. So the moment it is a Beyonce type question, I don't even know if you have a dash on her name, so I hope I'm spelling her name right. I must think letters to the left. And so immediately I'm going to write down the question and I'm going to identify which x's are in the so-called incorrect place. Now you notice when I write down, I often leave gaps so that I can do the same thing to both sides. So who's in the wrong place here? Well, this take away 3x is in the wrong place. It's not on the left. So how do I undo taking away 3x? I'm going to add 3x because those two will cancel each other out. But what you do to one side, you do to the other side. So that was my first step. Identify what's in the so-called wrong place and get rid of it. So now the next step, I'm pretty sure said collect up like terms. So these two are like terms. So 3 isn't, but take away 4x plus 3x is minus 1x. 3x take away 3x disappeared and I'm left with 1. So now I'm back to a very standard topic 1 type equation. Okay, now there's 2 ways to solve this and I'm going to do both. I realized I didn't actually do both when I said I was going to do both last time. So some people prefer to move this around, so to put the negative x first and then the plus 3. So now I'm back to topic 1. How do I get rid of adding 3? I'm going to subtract 3, but you have to subtract 3 from both sides. So now these two disappear and I get negative x equals negative 2. How do I get rid of negative 1? Well, that's negative 1 times x. So I divide by negative 1 on both sides and I land up with x is 2. Now let me just show you that you don't have to do that. So, or you could just do 3 minus x equals 1 and do it without swapping the order. So the furthest thing from x is this positive 3. So I'm going to subtract 3 from both sides, which will land me up with negative x equals negative 2, which is exactly the same place as that. So you don't have to do this moving around of the terms once you become really comfortable. So right, there was our Beyonce type question. Right, let's try some more Beyonce type questions and let's write down some notes. Just a full, nice, neat note for this one. So first thing, I see x's on both sides, so this is a Beyonce question. And I'm just going to write full notes here because there's x's on both sides. So my first step is not to panic. I'm going to identify which x's do you want to get rid of. Which x's do you want to get rid of? Now, how I answer this in my head is I say, well, which ones are in the wrong place? Again, there's no wrong place, but you know what I mean. Now, the wrong place is always the right-hand side. The right-hand side is where I don't want my x's. So if I write out this question, leaving some spaces for me to work, so 3x plus 10 equals 1 minus 4x. If I color coordinate this, my blue step is I'm saying these are incorrect. I don't want them there. So now I say to myself, how do I get rid of subtracting 4x? How do I get rid of minus 4x? And the answer to that is hopefully you do the inverse operation, which is I add 4x and the golden rule. Because the golden rule says if you're going to add 4x to the right hand side to get rid of them, you must add 4x to the other side. So now, sorry, I'm going to have to go down to get some more space. Now I pause and I simplify both sides. So I just neaten up both sides of the equation so I can see what I'm now dealing with. So pause to simplify both sides. So 3x plus 4x is now 7x. So I get 7x plus 10. 1 is still there. Let me actually give myself some space. So equals 1. And minus 4x plus 4x disappears, which is what I wanted. Now we're back to an easy equation. Now I'm going to continue writing down my steps because in my easy equation is what is attached to x that I need to get rid of. And here there are two things attached to get rid of, that are attached to x that I need to get rid of. And that is the plus 10. So there's plus 10 and there's a 7. Now which one do I get rid of first? I'm not going to write down this note because hopefully we're quite good at it now. Always get rid of things what's furthest away from x first. So how do I get rid of adding 10? I need to subtract 10. So subtract 10, but what you do to one side, you do to the other side. So I land up with 7x only, and that equals negative 9. And now how do I get rid of the 7? Well, I say, how is that 7 attached? And I divide by 7 on both sides. So 7 divided by 7 is 1, so I land up with just x. And the other side I get minus 9 over 7, which doesn't simplify. Now again, don't freak out if you get a fraction answer. It's completely acceptable and expected because we try to make these questions ones that you can't guess. So what notes have I missed out on? I said what is attached to x that I need to get rid of, and I kind of just need to add in the line here that says get rid of them one by one. Get rid of them one by one. And how do I do that? I do that by a process of inverse operations and the golden rule. So I haven't written comprehensive notes on that because that was more video 1. So these are hopefully our comprehensive notes on Beyonce type questions. Identify the x's that you don't want in that place and get rid of them, but don't forget the golden rule. Okay, now let's try these steps in our next question. Last example of Beyonce. This is Beyonce because I have x's on both sides of the equation. So I identify which x's I don't want there, and I don't want minus 2x over here because I want to the left, letters to the left. So I'm going to add 2x on this side, but the golden rule says I need to add 2x on that side. Now I pause. My step was to pause and add like terms. So it's 3 and minus x plus 2x is plus x. Minus 2x plus 2x disappears and I get 7. Now I could swap the order around, but hopefully I'm getting better at this. How do I get rid of this 3? I'm going to subtract 3, but what I do to one side, I do to the other side. And so I get x is 4. Now just to show you how you check an equation, if I put x is 4 in here, on my calculator I do 3 take away 4 and I get minus 1. Now if I put 4 in there, I put my calculator and I go 7 minus 2 times 4 and I get minus 1. And if I get the same thing, I know that this is a solution, because it makes this value for x makes the left-hand side and the right-hand side equal. Right, on to the next one. Oh, this is also Beyonce. Who knew? So let's have a look. I have 3 take away 4x equals minus 3x plus 1. Which x's are in the incorrect place? Minus 3x. So I'm going to add 3x, inverse operations, but what I do to one side, I do to the other side. I pause to add like terms, so this is 3 minus 4x plus 3x is minus 1x. These two are like terms, so I add them together and they disappear to just 1. How do I get rid of what's furthest from x first? How do I get rid of the 3? I'm going to subtract 3 on both sides. Collective like terms, these disappear, which was the whole point, so I get negative x equals negative 2. And finally, how do I get rid of negative 1 times x? I divide by negative 1 on both sides, and eventually I get x is equal to 2. Again, I would check this on both sides and you'll see if you're right. So you'll see how Beyonce type questions start with feeling like they're really long-winded, but you actually get really good at them. Okay, so finally our last question, which isn't a Beyonce question. I chose this one just because I think it was different, and so I thought let's try it. So exactly the same steps as usual. What is attached to x that I want to get rid of? There's a minus 4, there's a divide by 4, and there's a plus 1. So this is pretty standard. Now which one do you get rid of first? We've practiced this. That's a separate term. So we first get rid of the separate term, which means I need to add 4 to both sides. So my 4's disappear, and I'm simply left with x plus 1 over 4 equals 7. Okay, now the question is, do I get rid of the 4 first, or do I get rid of the 1? Now, this is where our mistakes happen a lot in this type of question. And this is exactly why I say always get rid of the denominator first. Up until now, it actually hasn't mattered which one we got rid of first. But here it does. And it matters because this plus 1 isn't actually plus 1. It's plus 1 over 4. Because that denominator of 4 is attached to the x and it's attached to the 1. And so what I need to do here is I have to first get rid of that denominator because it's attached to the 1 as well. So I'm going to multiply by 4 on both sides and get rid of it. Then I'm left with x plus 1, which is 28. And now I can subtract 1 because it's no longer attached to the denominator. It's on its own. So I can subtract it. Now, most people will subtract 1 first. And watch what happens if you subtract 1 first. If I went back here and I subtract 1 first, people say minus 1 and then they minus 1. Now, what people do is they simplify those 1's, but you can't simplify those 1's because the 1 isn't 1, it's 1 over 4. So then people get x over 4 equals 6. And when they multiply by 4, they get 24, which is completely different. So you absolutely can't do that. So in order to try and make it easy for ourselves, I always just obey the rule. Get rid of your denominator first. Okay, so that's the end of this video on this topic. What 2 things did we learn here? What we learned is this type of H example of where there's a denominator, and I said always get rid of a denominator first. It makes your life easier. And don't forget to start by getting rid of things furthest away from x first. Then we did the Beyonce type questions, which is where there's letters on both sides, and the whole point is get your letters to the left, to the left, to the left, which is why we call them Beyonce type questions. I'm not going to write down a summary, only because this example here of E, where we wrote down a nice step-by-step instruction, that's probably the best summary for what this type of lesson was about. So now, we need to get on to practicing these so we can really build our confidence. Well done, keep going.